Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss a very famous method. The name of the method is variation of parameters. This method applied to solve a linear differential equation of second order with variable coefficient. Or also we can apply this method a linear differential equation more than second order, means 3 order, with constant coefficient. It means we can solve with the help of this method number 4, variation of parameters. We can solve a linear differential equations of second order with variable coefficient. We have discussed this topic in last lecture in detail. And also linear differential equation of second order with constant coefficient. This topic we have discussed in last lectures. Variation of parameter method is very useful in a differential equation to solve a linear differential equation of second order with variable coefficient and also a linear differential equation of second order with constant coefficient. So here we want to discuss about this method. What is procedure of the method? How we can variate the parameters in our given question. And we will solve both type of problem with the help of this method, variation of parameter, differential equation of second order with variable coefficient. First problem is this topic, and other problems are on the topic linear differential equation of second order with constant coefficient. So we want to solve a problem based on both topics with the help of method number 4, variation of parameter. Other methods we have already discussed in last lecture. So we want to start to proceed how we can solve the problem with the help of variation of parameters. Now, method 4, variation of parameters. To solve a linear differential equation of second order with variable coefficient and also linear differential equation of second order with constant coefficient. What type of problem we can solve with the help of this method, variation of parameters. So here what is type of general differential equation we discuss here. So here type of general linear differential equation of second order with variable coefficient. With variable coefficient or constant coefficient is given as follows. This is equation 1. This equation 1 is known as a linear differential equation of second order with variable coefficient. Here A multiply A, second order derivative multiply with A, and first order derivative multiply with V, and only y derivative, y dependent function, y is dependent variable, that is multiply by C. So we see that here to left hand side of the given differential equation, in each term multiply by 3 elements, that is A, B, C respectively. A in first term with second order derivative, V in second term first order derivative, C in third term with dependent variable y. Where here A, B, C are function. If condition, number 1 condition, if A, B, C are function, A, B, C are functions here. ABC are functions. Then this equation 1 is known as a variable coefficient. Number 2, if ABC are constant, then this equation is known as a constant coefficient. So here ABC are functions of x or ABC are constant, and in right hand side is x. X is also function of x here, always, not constant. So x is dependent variable, x is independent variable, and y is dependent on x. Y is some function of x. We want to find out the value of y from given equation 1. So we will apply here the method 4, that is known as a variation parameter, to solve equation 1. If equation 1 is linear differential equation of second order with variable coefficient, or equation 1 may be linear differential equation of second order with constant coefficient. So with the help of this method, we can solve both type of linear differential equation. Here d over dx is d. This is the differentiation operator with respect to x. D is known as a differentiation operator with respect to x. So this is represented d over dx. D over dx notation y capital D. In any place in differential equation, d capital D means differentiating with respect to x, where x is independent variable here. Now we want to define a linear differential equation of second order with variable coefficient and constant coefficient. So what is general type of equation of this topic? So here A is number, A is function or number. First we take A is function. A is function multiply with second order derivative of the differential equation in first term. In our first term of the given differential equation, there is second order derivative. A is any function multiply with first term. In first term, A is a function multiply in first term. And B multiply in first derivative, first differential coefficient in second term. And C is also multiply with dependent variable y in third term. And in RHS x is also the function of x. So here y is also function of x, say y is equal to fx. Y is always here function of x because x is independent variable in our equation. So this differential equation is known as a linear differential equation with variable coefficient of second order. Now here we will discuss about the method of variation parameter, and we discuss in detail what is the procedure, how to solve a problem based on general linear differential equation of second order with variable coefficient and constant coefficient. So here this equation 1, a d2y over dx2 plus b dy dx plus cy equal to x. Here a, b, c are function. A, b, c are function of x. Equation 1 can be solved with the help of following method. A, b, c are function of x. Then equation 1 known as a linear differential equation of second order with variable coefficient. Next same equation, this a d2y over dx2 and plus b dy over dx and plus cy equal to x. This equation 2. If a, b, c are number, then 2 known as a linear differential equation of second order with variable coefficient, this constant coefficient. This is constant coefficient and this is variable coefficient. Here ABC are function of x, then variable coefficient. Here A, B, C are number, then this is constant coefficient. So with the help of this method, number 4, variation of parameters, we can solve both type of differential equation. So here one by one, we want to solve problem of linear differential equation of second order with variable coefficient, and also linear differential equation of second order with constant coefficient. So first we want to discuss about the method in detail. Now, apply method 4, variation of parameters to solve given equation 1, given differential equation 1. To find particular integral of 1. This is the equation 1 here. A d2y over dx2 plus b dy dx plus cy equal to x. This is general equation. Our question is in this type. Our question in same type as a 1, as a given general equation 1. Our question also type is this. ABC are here function. ABC are here may be constant. ABC may be function. Or ABC may be constants. ABC may be constant. If these are functions, then equation known as a linear differential equation of second order with variable coefficient. If these are numbers or constant, then this equation is known as a linear differential equation of second order with constant coefficient. And x always is a function of x. X is on right hand side. So here now we start the solution method about the formula. How it is work in a differential equation to give the answer, to find out the solution. So let the complementary function be. What is the complementary function? First we find out the complementary function of equation 1. We have discussed in last 2 chapters. In one chapter is linear differential equation of second order with constant coefficient. Then there we find out the complementary function and particular integral. So here first we find out the complementary function. In second chapter we find out we have already solved a linear differential equation of second order with variable coefficient. So with the help of last 3 methods, we find out the complementary function. So in this method, when we start this method, then we already know a complementary function of a given differential equation. If you don't have a complementary function, that is not possible to find out the solution. First we find out the complementary function, means complementary function is already known of a given differential equation. Then we can find the particular integral. So here we considering, this is the general linear differential equation with variable coefficient or constant coefficient. So here we considering that y is equal to, let the complementary function of 1 of equation 1 be this equation 2, y equal to a by 1 plus b by 2. This is the complementary function. A and b are arbitrary constant. y1 and y2, these are 2 solutions of equation 1. y1 and y2 are 2 solutions of equation 1. If y1 and y2 are 2 solutions of 1, then y1 and y2 satisfy to 1, where a and b are constant, arbitrary constant. In our complementary function, there are number of constant equal to the order of the differential equation. If differential equation is the order 2, then their arbitrary constant are also 2. If the order of the differential equation is 3, then in complementary function of the given equation of order 3 are number are 3 constants in complementary function. So here this is given differential equation of 2 order. So be considering here complementary function of the general given differential equation 1, that is a and b. A and b are complementary function. Y1 and y2 are two solution of our given differential equation. So combination of arbitrary constant and solutions, linear combination. This is the linear combination of arbitrary constant and solutions. A is a arbitrary constant and y1 is the solution of the given differential equation, first solution. So ay1 plus by2. This is the complete complementary function of our given differential equation. So we consider here y equal to a by1 plus b by 2. This is the complementary function of given equation 1. This is equation 2 represented by equation 2. This is as calculated in last chapter in detail. How we can find a complementary function of a given differential equation. Given differential equation may be any type of differential equation of variable coefficient or constant coefficient. There is more than one order. Minimum order is 2. Now let us consider the particular integral of 1. First of all, we are taking a complementary function of given differential equation, that is a by 1 plus b by 2. A and b are arbitrary constant. Y1 and y2 are functions. Y1 and y2 are solutions of differential equation. Our differential equation have two order. So there are two solutions of the given differential equation, that is y1 and y2. So the linear combination of arbitrary constant and solution is a by 1 plus b by 2. This is the complete complementary function of given differential equation 1. So that is complementary function y is equal to a by 1 plus b by 2. Now we want to next complete particular integral of the given differential equation. So we change a. A is arbitrary constant. A change in u. U is function. A convert in u. And v convert in v. U and v are function. A and b are constant. Constant convert in function. So now u and v are function and y1 and y2 are solutions of the given differential equation. So next is combination of given two functions and two solutions. So we get here next y equal to u by 1 plus b by 2. This equation 3. This is complete PI, particular integral of 3. Now complementary function plus particular integral, that is complete solution of the given differential equation. First is y is equal to a by 1 plus b by 2. This is complementary function. This is considering function, complementary function. We consider that is the complementary function of our given differential equation. Now in place of constant, we putting some function. A convert in some function u and b convert in some function v. And the linear combination of the function and solution u by 1 plus b by 2. That is particular integral of our given differential equation. So now equation 3 is particular integral. Equation 2 is complementary function. Equation 2 is complementary function. Equation 3 is particular integral. So now complete solution is complementary function plus particular integral. So here be considering a is arbitrary constant, convert into some function u. So what is the value of u here? We find out the value of u and some value of v. After finding the value of u and v putting in the question, then we get complete solution. This is the main process to find out the solution. So here y equal to u by 1 plus b by 2, this equation 3, where u and v are unknown function of x, which we have to find later. Now, with the help of equation 3, verifying 1. This is the pi of 1. So this solution verified to 1. Now, how it is verified to 1? So here by differentiating y with respect to x. So this is dy over dx. This is the value of dy over dx. dy over dx means y dash. First derivative with respect to x of y. So here y dash. Now we apply here product formula in u by 1. U is first function, y is second function. So we apply here product formula. Here putting u constant, d of u by 1 and plus d of u b by 2. D means differential. This is y dash d of y. We apply this formula. dy means dy. dy means dy dx. This is y dash. Okay. Here we apply product formula. U constant, differential of y1 dash. Here is y1 dash. Plus y1 constant, differential of u dash. U y1 dash and plus y1 u dash. This is product formula. Plus b constant, y2 dash and plus y2 b dash. This is equation number. Next, this is equation number. Now again differentiating with respect to x to 4. This is equation 4. This is equation 4 here. 4 number equation. Now differentiating with respect to 4. With respect to x to equation 4, then we get here. What we get here? Y double dash. This is y double dash. This is y double dash. Here u y dash plus y1 u dash plus by dash plus by2 b dash. So now here putting again differentiating. U by 1 dash plus b by 2 dash. This is same equation I am writing this. Okay. Here u by 1 dash. U by 1 dash and b by 2 dash. This is u by 1 dash first term. And next is b by 2 dash second term. U, b are constant here. So this is I am writing first. And y1 u dash and y2 b dash. These two terms I am writing last. So after writing we get this equation. U by 1 dash plus b by 2 dash. Y1 u dash plus y2 b dash. This equation number 5. So that u b satisfy the following equation. So this result must be 0. This result must be 0 here. So we are taking this result 0. U dash y1 plus b dash y2. This equal to 0. This equation 6. Putting from equation 6 in 5. This equation putting here. This result must be 0. This result putting here 0. Then we get y dash equal to u by 1 dash plus b by 2 dash. This equation 7. This result must be 0 because u and v satisfy the following equation. Now we get equation this. After putting this value 6 in 5, then we get this equation 7. Y dash equal to u by 1 dash plus b by 2 dash. Again differentiating 7 with respect to x. Then we get here y double dash. Here again product formula using here u by 1 dash. So we apply here formula equation 7. We apply here d of y dash equal to d of u y1 dash and plus d of v y2 dash. We apply this formula. So here product formula we apply here. U constant differential of y1 dash plus y1 dash constant differential of u, and b constant differential of y2 dash constant differential of b. So we apply here both term, in both term product formula. After apply formula we get result this. Y, this is the differentiation of y dash with respect to x. So we get y double dash. Now u y1 double dash plus u dash y1 dash. Here u constant differential of y1 dash. Y1 dash means y1 double dash. Here differential of u dash y1 dash is constant plus b constant y2 double dash plus b dash y2 dash. This is equation 8. Now substituting this value y dash and y double dash in equation 1, then we get. Now this equation 1 or this, both are same. So putting here, our equation here a d2y over dx2 and plus b dy over dx plus c y is equal to x. Okay. So now this is a y double dash plus b y dash plus c y equal to, this result equal to x. So our here first solution is y1 of this equation. So y1 is putting this verify to this. Y1 result is verify. So putting a y1 double dash plus b y1 dash plus c y1 equal to x. Next result y2 also verify this. A y2 double dash plus b y2 dash plus c y2 equal to also x. So this we have get these two equations. Okay. So now these two solution verify here. So putting here now a. This is value of y double dash. This is second derivative of y. A d2y. I am writing here equation. A y double dash plus b y dash plus c y equal to x. This is general given differential equation. This one and this one both are same. Equation 1 and equation 1. This is same equation. So putting value of u y1 double dash plus u dash y1 dash plus b y2 double dash plus b dash y2 dash plus b. This is the value of y dash. U y1 dash plus b y2 dash plus c. This is the value of y. U y1 plus b y2 equal to x. This is equation 9. Now this implied that here u taking common, in this term u common, next u in this term common, next u in this term common. So now writing a y1 dash plus b y1 dash plus c y1 and plus next b common in this term, b common in this term and b common in this term. So after taking b common, a y2 dash double dash plus b y2 single dash plus c y2 plus a common, u dash y1 dash plus b dash y2 dash equal to x. This is equation 10. Here we know that y1 and y2 satisfy the equation 1. After satisfying equation 1, we get this a y1 double dash plus b y dash plus c y1 equal to 0. Similarly, a y2 double dash plus b y2 dash plus c y2 equal to 0. Okay. So we get here this result is 0 and this result 0. After putting this result 11 and 12 in 10, putting value from equation 11 and 12 in equation 10, then we get. Finally, this result is 0. This result must be 0. And this result must be 0. Coefficient of u is 0. Coefficient of v is 0. So we get this result here. This u dash y1 dash plus b dash y2 dash equal to x. This is equation 12. Solving equation 6 and equation 12. Equation 6 we are putting 0 and equation 12. Now these results are equal to 0. We have discussed here this result. This is equal to 0 and this result equal to 0. So this result are 0 here. This is the equation, general differential equation. We have taken this equal to 0 because we find out the complementary function. First, when we find out the complementary function, then we right hand side putting 0. Then we get two solution. So right hand side is 0 here. I am putting right hand side is 0 this. So here this is not x equal to, this is 0. And this is double dash, this is also 0. And this putting y1 dash, so this result is 0. This result also 0. So this equation and this equation equal to 0. This value putting in our equation number here 10. This result 0. So after putting 0, we get equation this. So here result u dash y1 dash plus b dash y2 dash equal to x. This equation 12. Solving equation 6 and equation 12, then we get value of u. u dash y1 plus b dash y2 equal to 0. This equation 6. u dash y1 dash plus b dash y2 dash, this equal to x. This equation 12. So to solve 6 and 12, apply cross multiplication. Which formula we apply here? We know here a1x plus b1y plus c1z. c1 equal to 0. a2x plus b2y plus c2z. This equal to 0. a1x b1y plus c1. This is linear equation. Linear equation of two variable x and y here. a1x and b1y plus c1. a2x plus b2y plus c2. b2y plus c2. So now how we can solve? Apply here cross formula. Cross product formula. Cross product. So formula is cross product is b1, b2, c1, c2 and y upon here c1, c2 and a1, a2 and 1 upon a1, a2 and b1, b2. So this formula basically known as a cross multiplication formula. This multiply minus this multiply minus this multiply minus this. So we apply here determinant of this one. So solving 6 and 12, apply cross multiplication formula. Here u dash y1 plus b dash y2 minus 0 equal to 0. u dash y1 dash plus b dash y2 dash equal to minus x. X taking this side. So minus x equal to 0. This equation 6 and this 12. This equation basically depend on this equation. a1x, b1y, c1 equal to 0 and a2x, b2y, c2 equal to 0. So 13 and 4, 14. Both are two variables linear equation. So we apply formula this x upon determinant b1, b2, c1, c2. Y upon c1, c2, a1, a2. And 1 upon a1, a2 and b1, b2. Here is cyclic. We are usually here cycle. B goes to C, C goes to A and A goes to B. So B to C, B to C and C to A and A to B. So B goes to C and C goes to A and A goes to B. So in X denominator, there is no A element. Coefficient of X is not there. Only coefficient of Y and constant are there. In Y, there is no coefficient of Y here. Here coefficient of constant and coefficient of X here. And in constant, this is constant term, there are not constant number, only the coefficient of X and coefficient of Y. So this is cross multiplication formula. Formula of cross multiplication using, so now we have here. Now X is U, in our question is U, here is X. Comparison this to this and apply all value here, then we get this result. U dash upon here B1, B1 means Y2 and Y2 dash, B1, B2. This is B1 and this is B2, Y2, Y dash. And C1, C2, C1 is 0 and C2 is minus X, C1, C2, this is C1 and this is C2. And B dash is C1, C2, 0 minus X and A1 is Y1 and Y1 dash, and this number 1, Y1 and Y1 dash, Y2 and Y2 dash. So now this equation 16. After completing this U dash, we get U dash. What is U dash? U dash means this result equal to this taking here. Then we get this equal to this upon this. Now this minus this, determinate like this, y2 and y2 dash, 0 and minus x. After solving this minus this means minus x y2, x y2 and minus 0. So we get only this result, x y2 upon this. This equation 17. This is the value of u dash. U dash equal to minus x y2 upon this. Similarly, we get b dash. B dash equal to b dash upon this equal to this. And after cross multiply, then we get value of b dash is this. Y1x upon y1 y2 dash minus y2 y1 dash. So now b dash equal to result this. This is v2 dash. Okay. B dash. Now we have from equation 18, we have the value of u. We already consider u dash. This is u dash. U dash is du over dx. U dash is du over dx. Differentiating with respect to x, to u. So du over dx, this u dash, this equal to minus x y2 upon this. Denominator is same in both value. This equation 20, 21. Now integrating with respect to x on both sides to 18, then we get. Here is du, dx taking this side. Here after cross multiply, dx taking this side. This is variables are separable. Variables are separable. Variable are separable. Here we apply formula. So now du equal to this and u. Here is 1 du. So u equal to this. This is the value of u. We can find value of u with the help of this formula. U is y2 and negative. V is y1 and positive. You remember this. In u minus negative x, here is y2 upon y1 y2 dash minus y2 y1 dash. This is formula. And integrating on both sides this. This is the integration dx, this formula. Now we have from equation 20, we have this dv over dx. This is b dash. B dash means dv over dx. Differentiating with respect to x to b. So this result is this y1x upon same. This same. In b there is y1. In u there is y2. X is common. U is negative and v is positive. So we get this. This is the here dv. y1x upon y1 y2 dash minus y2 y1 dash dx. This equation 24. After integrating, we get the value of v. B equal to y1x y1 y2 dash minus y2 y1 dash dx. This equation 25. Okay. With the help of 20 last equation, which equation? This u is 22 and 25. We can find with the help of 22 and 25 the value of u and v. After putting value of u and v, then we can find the particular integral. Pi is u y1 and plus b y2. This is pi. Particular integral this. And complementary function CF. CF is a by 1 plus b by 2. Okay. So this is the particular integral and this is the complementary function. After adding this result, a by 1 plus b by 2 and plus u by 1 and plus b by 2. This is the complete solution of the question. This procedure we apply in the question to solve a linear differential equation second order with variable coefficient or constant coefficient. So first we are taking problem of constant coefficient, linear differential equation of second order with constant coefficient. After it, we are taking the problem, we will solve the problem of linear differential equation of second order with variable coefficient. But both type of problem we will solve with the help of variation of parameter. Now, we are discussing the steps. How many steps we are applying in our question to get the answer, to get the solution. So, step 1. What is step 1? Step 1, finding complementary function of given problem. First of all, anyway, any type of method we apply in our question, but we will find first complementary function. So complementary function is ay1 plus by2. This is the CF. CF is ay1 plus by2. CF by2. Step 2. Step 2, finding particular integral. A convert in u and B convert in v. Solutions are no change. So u by 1 plus b by 2. This is the complementary function. Here u and v are some function of x. Step 3. Finding value of u and v with the help of the following formulae. We apply this formula to find out the value of u and v in our question. U is equal to minus x. X is the function of x which is given in right hand side of the given question, given problem. Capital X is the function of x which is given in the right hand side of the problem. That is the function of x. So minus u is negative. Capital X into y2 upon y1 y2 dash minus y2 y1 dash dx. Using this integral formula, we can find the value of u in our question. Now next, v equal to integration y1x. X is the function of x which is given in the right hand side of the problem. So y1x. What is y1? Y1 is first solution. What is y2? Y2 is second solution. What is y1 dash? Y1 dash is the differentiation with respect to x of y1 first solution. What is y2 dash? Y2 dash is the differentiation of second solution with respect to x. So all values putting in this formula, we can find the value of u and v. And y1 and y2 we find out in complementary function. Then we find out the complementary function first and particular integral u by 1 plus v by 2. And u and v find the value of this formula. After step 4 last, y equal to complementary function plus particular integral we are adding here. So y equal to a by 1 plus b by 2 plus u by 1 plus b by 2. This is the complete solution of given 1 by the variation of parameter. Okay. So now we will solve here one problem based on method 4, variation of parameter. The problem is in linear differential equation of second order with constant coefficient. First we want to discuss about the problem which is constant coefficient. Constant coefficient means only in multiply in each term by the number. Each term multiply by the number, not functions there. So problem 1, based on the method of variation of parameters to solve a linear differential equation with constant coefficient. So here solve d2y over dx2 plus y equal to cosec x. d2y over dx2, this is the second order derivative, plus a plus y into 1. One number here multiply with y, 1. This is 1. And y equal to cosec ax, cosec x. This is x. Okay. This is the value of x here. This is y. So this problem can be differential equation of second order with constant coefficient. Now solution. d2y over dx2 plus y equal to cosec x. This is problem 1. Equation 1 can be written as in D form, function form. D is d over dx, we have discussed already. So now writing this, d square plus 1 by equal to cosec x. D square plus 1 by equal to cosec x. Now finding complementary function of 1. Because this is differential equation of second order with constant coefficient. But we have discussed in detail about the differential equation with constant coefficient in last chapter, how we can find the solution, how we can find the complementary function, how we can find the particular integral. So there will be no problem to find out the complementary function of this question. Okay. So here, finding complementary function of 1. D square plus 1 into y is equal to cosec x, or d2y over dx2 plus y equal to cosec x. So this is the linear differential equation of second order with constant coefficient. First of all, we find out complementary function. So to find out complementary function of given problem, so first we putting right hand side equal to 0. Here putting right hand side equal to 0 in equation 2. Then we get here d square 1 y equal to 0. When we find out the complementary function, if we find out the complementary function, then right hand side must be equal to 0. So this result is 0, x taking here 0. Now finding auxiliary form of 3. What is auxiliary form of equation 3? Auxiliary form means that there is a equation in m form. So putting d equal to m, capital D equal to putting m and removing y from 3. So we get m square plus 1 equal to 0. This equation 4. M square plus 1 equal to 0. So m square equal to minus 1. Minus 1 is I square. So here m square is minus I square. Minus 1 is I square. So m equal to plus minus I. This is imaginary roots, plus minus I. There are two roots, m equal to plus I and m equal to minus I. So m equal to plus minus I. There is no real part. Real part is 0. 0 plus minus I. This equation 5. This has an imaginary roots. Imaginary roots of an auxiliary form. So m equal to is alpha plus minus I beta. This equation 6 we have discussed in last chapters in detail. So alpha plus minus I beta, after comparing in 5 and 6, compare in 5 and 6. 5 and 6. Then we get here alpha 0 and beta 1. Alpha and beta. So we apply here formula. Formula is C1. Formula is CF, complementary function. CF is e to the power alpha x in bracket C1 cos beta x and plus C2 sin beta x. This is formula. Sin beta x. So here alpha is 0, e to the power 0x, and C1 beta is 1 cos x plus C2 sin x. C1 and C2 are arbitrary constant. So this is arbitrary. C1 is a cos x and plus b sin x. Okay. So now here a cos x plus b sin x, this is CF. Complementary function of 1 is CF is this. Here cos x and sin x, there are two solutions. Here y1 is cos x and y2 is sin x. y1 and y2 are two solutions. y1 and y2 are two solutions of equation 1. These solutions verify to 1. So now here then y1 dash. What is differentiation of y1 with respect to x? y1 dash. Cos x means sin x minus sin x. Minus sin x. Cos x means minus sin x. y2 dash is sin x, differential of sin x is cos x. Cos x differential of minus sin x. Minus sin x this. And capital X is cosec x. This is 9. Step 2. This is step 1. What is step 1? Step 1 we find out the complementary function of given problem. So here complementary function we find out a cos x plus b sin x. Here a y1 plus b y2 comparison, then we find y1 and y2. So y1 is cos x and y2 is sin x here. Now differentiating y1 and y2 with respect to x, we get y1 dash, that is minus sin x, and y2 dash, that is cos x. And x is given in our question, that is cosec x. Step 2, pi, particular integral of 1. What is pi? This a number convert in u y1 plus b y2. y1 is cos x and y2 is sin x. U cos x plus b sin x. This is equation 10. Now finding value of u and v with the help of given following formulae which we have proved here. So u is this, u equal to minus x y2 upon y1 y2 dash minus y2 y1 dash dx. And b formula is b equal to y1x y1 y2 dash minus y2 y1 dash dx. From equation 11 and 12 we find out the value of u and v. Then step 4 complementary function plus particular integral. We are adding complementary function and particular integral. Then we get complete solution. Now we have the following formula to find u. We apply equation 11. So u is equal to capital X is minus cos x, minus x. Putting in 11. So minus cosec x, y2 is sin x. And upon y1 is cos x, y2 dash is minus y2 dash sin x ka, y2 dash is sin x ka differential cos x. And minus sin, y2 is sin x, differential of sin x is y1 is cos x, differential of cos x is minus sin x this. So now this cos square x, this cos square x and plus this sin square x. So this is 1. Then we get here cos x, this cancel. Here is sin x equal to 1 upon cosec x. So we write this formula here. So cosec cancel, this is 1. So here minus 1 only, minus 1 dx. So minus 1 dx, u is equal to minus x plus minus x. Minus x this. Minus x plus a. Or only a, not minus x, this result. Now next, similarly we can find value of b with the help of formula b. So now here formula b is equal to integration x plus x here y1. Now what is formula of b? y1 upon y1 y2 dash and minus y2 y1 dash. This formula and into dx. So now putting value of here y1. X is cosec x. What is y1? What is value of y1? y1 is cos x into cos x upon y1 dash cos x into cos x minus sin x into minus sin x and this dx. So this equal to integration. This is cosec x and cos x. Cosec x and cos x. Cos is 1 upon sin. And this is cos x. And upon is cos square x plus sin square x. And this dx. So this is cos upon sin. Cos x upon sin x. This is cot x. So now this is 1 cot x and upon 1 dx. Integration of cot x, log sin x. Log sin x. So this is the value of v. Now complete solution is y is equal to a y1 plus b y2 and plus u y1 and plus b y2. So what is answer A? A y1 a cos x plus b y1 b sin x plus u. What is value of u here? U is minus x. In bracket minus x cos x and plus b is sin x and into log sin x. Okay, sin x and into log sin x. Log sin x. Log sin x. So this is the complete solution of the given problem. Okay, this is complementary function and this is particular integral. So this is the addition of complementary function and particular integral. This is the complete solution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.